I did want to do two examples, at least off of the homework. And we had 1 through 6 on that worksheet on graphing parabolas. And of course, I told you that they were all parabolas, so that allowed us to use our shortcut. If we weren't told that they were parabolas, the hint would be, of course, the x squared. The fact that that's the highest power, there's nothing other than x squareds in there, would indicate that those can be graphed as parabolas. If there was an x to the third or any power higher than 2, then obviously it's going to be a different shape. So I want to start out with just number 1. Hopefully everybody got that one to work out. I just want to give you something to compare to. We had y equals x squared plus 5x plus 4. And if we go to graph that, first thing to remember is to find the roots. And to find the roots, there's two things you need to do. You set y equal to 0, and then you factor the other side. So we got to see what that factors into. X squared would be x times x. 4 can either be 2 times 2 or 1 times 4. We see it's got to add up to 5, so we're going to try that 1 times 4. So plus 1 and plus 4. And we're going to double check it to make sure that gives us that proper center term. If you recall, that center term comes from the outside product and the inside product added together. So we've got x times 4 is 4x on the outside. On the inside, we've got 1 times x is 1x. 4x plus 1x is 5x. And that is what we wanted. So that is the proper factoring. Now, remember the zero product rule said if two things multiply to make 0, at least one of them has to be 0. So what this is telling us is that either x plus 1 equals 0 or x plus 4 equals 0. And if we solve those, this one we would subtract 1 to get x equals -1. This one over here we would subtract 4 from each side to get x equals -4. Those are the roots of that equation. So one's at -1 here and the other one's at -4. Now our second step was to get the axis of symmetry. And the axis of symmetry was always directly between those roots. So we found it by averaging the roots. -1 plus -4 over 2 in this case. -1 plus -4 is -5. Divided by 2 is -2.5. So our axis of symmetry is here at -2.5. That was step 2. Step 3 then is to find the vertex. We find the vertex by putting this x coordinate for the axis of symmetry back into the original equation or into the factored equation, either one, to figure out what y has to be. I'm going to use the factored equation here. Y equals x plus 1 would be -2.5 plus 1 times x plus 4. So -2.5 plus 4. Well, -2.5 plus 1 is -1.5. -2.5 plus 4 is a positive 1.5, which gives us -2.25. So the y coordinate of that vertex is at -2.25. The x coordinate is on that axis of symmetry, -2.5. So -2.25 is somewhere in there. So that is -2.5, comma, -2.25, or -2.5, -2.25. And our parabola looks something like that. I also wanted to try number 5, because number 5 contains something we didn't get a chance to look at in class. And that is, instead of being just x squared, it's 2x squared. We didn't see anything like that in class in our examples on Monday. So when we go to find our roots, we set y equal to 0 and we factor the other side. But the first thing we see there is every number on that side is divisible by 2. So if I divide that by 2, what I'm left with, 2x squared divided by 2 is just x squared. 8x divided by 2 is 4x. And 6 divided by 2 is 3. So 0 equals 2x squared plus 4x plus 3. And now we can still factor that. This factors x and x make the x squared. And 3 will pretty much has to be 1 times 3. Let's double check the outside and inside products. On the outside, x times 3 is 3x. On the inside, 1 times x is 1x, and that does give us 4x, which is what we had there. Oops, get back here. So that's telling us that either 2 equals 0, which isn't possible, so we know that one can't be 0, or x plus 1 equals 0, or x plus 3 equals 0. Solving each of those, here we would subtract 1, get x equals negative 1, or over here, this one we would subtract 3 to solve for x to get x equals negative 3. So I've got negative 1 and negative 3. Now we can see where the axis of symmetry has to be, but let's go ahead and solve for it anyway. Our axis is at the average of those roots. So it's going to be negative 3 plus negative 1 divided by 2. Negative 3 plus negative 1 is negative 4 divided by 2 is negative 2, which, like I said, we could have just looked at those roots and saw that negative 2 is what's right in between them. And now we find our vertex. We put negative 2 in for x to see what we get for y. So y equals, I'm going to go back to the original equation. So 2 times negative 2 squared plus 4 times negative 2 plus 3. So negative 2 squared is 4 times 2 is 8. Oops, this was 8 here, not 4. This was 6, not 3. 8 times negative 2 is a negative 16 plus 6. So 8 plus negative 16 is negative 8. Negative 8 plus 6 is a negative 2. So the y coordinate of our vertex is at negative 2. So that puts it right there. That's it. X was negative 2 and y came out to be negative 2 also. And from that, we'll draw our parabola. You'll notice that one's actually a little bit narrower than the others because it wasn't just x squared, it was 2x squared. It's almost like a slope that makes the side steeper. Okay, so that's all we're going to do for parabolas in this unit, in this class. Like I'd said before, if you ever get stumped, you could always go back to just making a table, picking values for x and calculating what y has to be, and plotting points to draw the parabola. On our test, there will be at least one parabola to graph. Okay, so next, let's go back to our lines. And what I want to do is I want to explore some relationships between lines. One relationship we can have from lines might look something like this. I'm going to start out by graphing y equals 2/3 x minus 1. So when I graph that, of course, I start at the number that's not multiplying x. That's my y-intercept, is negative 1, so that's my starting point. From that starting point, my slope here, the slope is the number that does multiply x, has a rise and a run. So from that point, we rise 2, and then we run 3. That takes us to our second point on that line. But one of the relationships we want to look at today is going to look like this. This is a parallel line. One thing we can say about that parallel line as we look at it going across the graph is it's just moved up or down. Well, since it's moved up or down, we can look here, it's moved up 1, 2, 3 spots here. This second point would also move up 1, 2, 3 spots. If I look at that, if you visualize if this were on grid paper, you'd be able to see that is still from this point up 1 and over 3 to get to that second point. So that parallel line has the same slope as the original line. What is changed? There is a different y-intercept, a different starting point. So the equation for that line is still going to be 2/3 times x. The slope is the same. The y-intercept now has just gone up to +2. So for parallel lines, that's a very important relationship, is that those slopes are the same. It's just the intercept changes. So let's take a look at some questions related to that. First of all, find the slope of a line parallel to y equals -3/5 x plus 7. Well, the slope of this line created by that equation is just the number multiplying x. 5 disappeared on me. The number multiplying x is -3/5. The slope of the parallel line will be exactly the same, -3/5. So we might ask, find the equation of a line parallel to y equals 1/2 x plus 3 with y-intercept of -1. Well, again, I need my original equation, but the only thing I need from that original equation is the slope of that original line. And the slope, again, is that number multiplying x. It's the 1/2. What that tells me is the slope of my parallel line is also 1/2. It's the same as the slope of the original line. So when I go to write an equation, it's y equals 1/2 x. My y-intercept of -1 means it's -1. Well, we can continue down this line and we can go to, rather than giving you the y-intercept, giving you just a point that the line goes through. We can find the equation of a line parallel to y equals 3/2 x plus 5 and through the point 6, 5. So again, looking at this original equation, the only piece of information I need is the slope. That slope is 3/2, 3/2. So then for the parallel line, I know the slope is also going to be 3/2. So when I write the equation of that line, I know it's y equals 3/2 times x, but I don't know the y-intercept. I'm going to have to use this point to find it. So for now, I'm going to put the letter B in there for my y-intercept. To find out what B has to be, what that y-intercept has to be, I use this point, 6, 5. This is telling me that y is going to be 5 when x is 6. So 5 equals 3/2 times 6. The only thing left to solve for is B. So we do 3/2 times 6, which is 9. So 5 equals 9 plus B. Then we'll subtract 9. So 5 minus 9 is -4 equals B. So that means we go back up to our original equation here, not the original, but our parallel equation, and replace B with -4. So y equals 3/2 x. B is -4, so -4. That is the equation of a line parallel to y equals 3/2 x plus 5, but through the point 6, 5. Well, let's talk about another relationship. So we're going to start out with the line y equals 2/5 x minus, let's go -2. So graph that, we're going to start at -2. That'll be our first point. From there, we're going to go up 2 and over 1, 2, 3, 4, 5. There's our second point. Our line goes through those 2 points. Now, we want to find a line that is perpendicular to that. Perpendicular means, of course, that it forms a right angle. So that original line has a positive slope if our perpendicular line is going to have, let's say it goes through this point here, 5, 0. We draw it like this. The first thing we see is that it's going to have a negative slope. So the first thing about perpendicular lines is the slope is opposite for one. And opposite just means positive or negative, opposite sign. But we'll also notice the blue line, the original line was fairly shallow. That brown line, or perpendicular line, is relatively steep. So let's look at that. We know this here has to form a right angle. To look at how that can be a right angle from the graph here, let's take a look at our slope triangle. We had this triangle here. Obviously, that's a right angle because horizontal and vertical are always at a right angle to each other, always perpendicular. These two angles, this one and this one here, add up to 90 degrees because a triangle itself always adds up to 180. This one's 90, that leaves 90 for the other two. I call this one angle A and angle B. What that tells me is this angle here, if they're going to be perpendicular, has to be angle B, because A plus B adds up to 90 degrees. So to make that angle B, I would have to redraw this triangle with a different orientation, like that. And you see what happens is, this was a rise of 2 here. That now becomes a run of 2 on that triangle. This was a run of 5. It now becomes a rise of 5. And since it's opposite, it's actually a -5 going down. So the slope of that brown line, or perpendicular line, is -5 over 2. So the slope of that perpendicular is opposite The original was positive, this one is negative. It's also reciprocal. The original line was 2/5. This is 5/2. We switched them, and of course, it's negative. So if I ask you find the slope of a line perpendicular to y equals 2/3 x minus 5. Well, all I need out of this equation again is the slope. That slope is 2/3. So what that tells me is for my perpendicular, the slope is the opposite reciprocal. This is positive. The opposite would be negative. Reciprocal, this is 2/3. The reciprocal would be 3/2. So the slope of that perpendicular line is a negative 3/2, negative 3/2. Likewise, I could ask you to find the slope of a line perpendicular to y equals 3x plus 1. Again, all I need out of here is the slope. That slope, again, is the line or the number that multiplies x. That's a slope of 3. Now to graph it, we always made that 3/1. So we rise 3 and run 1. Putting it in that form is helpful for finding the perpendicular. For that perpendicular line, the slope is going to be the, oops, I screwed up here. It should have been negative 3x plus 1 is what I wanted there. So that slope is actually a negative 3. So for the perpendicular, this slope was negative, so my perpendicular is going to have a positive slope. This is 3/1, so the reciprocal is 1/3. So the slope of that perpendicular is a positive 1/3. So if I am asked, find the equation of a line perpendicular to y equals negative 3/4 x plus 3 with y-intercept of negative 2. So again, the only thing I need out of this equation is the slope. That's the number multiplying x. The slope there is a negative 3/4. Now I need to find the slope of the perpendicular line. So for that perpendicular line, the slope will be the opposite. This one's negative, so this will be positive. And reciprocal. This is 3/4, so this will be 4/3. So the slope of that perpendicular line is positive 4/3. Telling us that that equation is y equals 4/3 times x. It's always slope times x. Our y-intercept is negative 2, so minus 2. Just like the other ones, just like parallel, we can ask, find the equation of a line perpendicular to y equals 1/2 x minus 3 and through the point, excuse me, 2, 7. So again, from this original equation, all I need from that is the slope. The slope here is 1/2. It's 1/2 multiplying x. So for my perpendicular, that slope, it's opposite. So this is positive. This one's going to be negative. Reciprocal, this one's 1/2, so this will be 2/1, or just a -2. So to write that equation, I start as y equals -2 times x. I have to find my y-intercept. So I'm going to put plus b in there. I'll find that using this point, 2, 7. I have to go through that point, so that point has to make the equation true. So y is 7. So 7 equals -2 times x is 2 plus b. -2 times 2 is a -4 plus b. We solve by adding 4 to get rid of the -4. So 11 equals b. That's the y-intercept. So we go back up to this perpendicular equation and we replace b with 11. So y equals -2x. It's a positive 11, so plus 11. So let's look at just a couple of examples more, and then we'll move on. So you find the equation of a line parallel to y equals -4/3 x plus 2 and through 6, -3. Well, out of this original equation, we need the slope. That slope is a -4/3. Well, next we have to identify, we are looking for parallel. A parallel line has a slope that is equal. So the slope of that parallel line is also -4/3. So we start our equation, y equals -4/3 x plus, we're going to have to find the y-intercept yet, so plus b. We put in our point, 6, -3. That's saying that -3 goes in for y, and 6 goes in for x. So we combine, -4/3 times 6 is a -8. And to get b by itself, we add 8. So -3 plus 8 is 5 equals b. So replace this b with 5. Y equals -4/3 x plus 5. That is the equation of a line parallel to y equals -4/3 x plus 2 and through the point 6, -3. Find the equation of a line through 4, 1 and perpendicular to y equals -2/3 x plus 1. So again, this original equation, all I need out of there is that the slope is a negative 2/3. I am looking for perpendicular. Perpendicular means the slope is the opposite reciprocal. This slope is negative, so the perpendicular is positive. Reciprocal, 2/3 becomes 3/2. So 3/2, or positive 3/2, is the slope of that perpendicular. So we'll start out with y equals 3/2x plus, we do not know the y-intercept, so we put in b. We'll use our point 4, 1. 1 goes in for y. 4 is going to go in for x. So now we have 3/2 times 4 is going to give us 6 plus b, and we solve for b. So we're going to subtract 6 from each side, gives us -5 equals b, or b equals -5. So then we go back up to this equation, and we're going to replace b with the -5. Y equals 3/2 x minus 5. Now there are some variations on those that we can do. We might say find the equation of a line parallel to a line through this word is a little cluttered here, but 6, 1, and let's go 9, -1, that contains the point let's go through 6, 5. So these 2 points here are defining the original line. The original line parallel to the line that goes through those 2 points. And then the new parallel has to go through the point or contain the point 6, 5. So from these first 2 points here, all we need is the slope. To find the slope, I'm going to go back to that slope formula. So y equals m equals y2, which is 0.2, y coordinate is -1, minus y1, 0.1, y coordinate is +1, over x2, our second coordinate x value is 9, minus x1, 0.1, or x coordinate is 6. So we subtract there, 1 minus 1 is a -2, 9 minus 6 is 3. That can't be reduced, so we have a slope of a -2/3. Our parallel has a slope that is the same. It'll be -2/3. So we'll do y equals -2/3 x plus b again. We got to find b. To find b, we're going to use this given point that line has to contain the point 6, 5. So that's saying y would have to be 5 when x is 6. It has to make that equation true. So we have -2/3 times 6, which is -4. To solve for b, we add 4. So we got 9 equals b. So this equation here becomes y equals -2/3 x. Replace b with +9, plus 9. That is the equation parallel to the line that goes through those points and contains the point 6, 5. Similar to that, we might have find the equation of a line containing 8, 1 that is perpendicular to a line through 5, 7 and 8, 3. So again, for these original 2 points, the only thing I need there is the slope. So call it point 1 and 2. I've got y2 is 3 minus y1 is 7 over x2 is 8 minus x1 of 5. 3 minus 7 is a negative 4. 8 minus 5 is 3. So I get a negative 4/3 slope. For my perpendicular, the slope of that line has to be the opposite reciprocal. This one's negative, so the slope of the perpendicular is positive. Reciprocal, this is 4/3, so the perpendicular has a slope of 3/4. So we know the slope, so we can start the equation. Y equals 3/4 times x plus, we still have to find the y-intercept. We'll use that 0.81 that we were told has to be contained in that line. So that tells us that y is 1 when x is 8. So 3/4 times 8 is 6. We solve for b by subtracting 6. So negative 5 equals b. So we put that up here. Y equals 3/4 x. B is negative 5, so minus 5. Okay, so and there are other variations you can see on those, but I think you guys get the point. From what we did last Friday with finding equations from points and slopes and all that, you should be able to put the pieces together from there. Now, where we're going for our next steps. There's 2 things left to discuss in this unit, which means our unit test will be next week, Wednesday. So 1 week from today. Oops, Wednesday. I believe that is May 2nd. That'll leave us about 4 hours of lecture in Unit 5 before we have to do our last test, Unit 5 test. But anyway, our next topic that we're going to be talking about is going to be the topic of variation. And variation is describing how values interact with each other. Values interacting with each other can either be direct or inverse. And in direct variation, you're looking at if one value, I'm just going to label it x for now. Really, that's that independent value on the graph that we talked about. If that value gets larger, then the y value or dependent value also has to get larger. Or the opposite's true. If x gets smaller, y also has to get smaller. Now, if you're thinking of terms of lines, that means it's a positive slope. You can see here if x gets larger, y gets larger. X gets smaller, y gets smaller. But it doesn't necessarily have to be a linear relationship. It could be, get my colors to work here. There we go. It could be a parabola or an exponential curve or whatever. But you can still see there, those x values get bigger, y values get bigger. We'll look at the mathematical relationships there on Friday. For inverse, it's the opposite. If x gets larger, y has to get smaller. Or if x gets smaller, y has to get larger. So if that were a linear relationship, it would have a negative slope. You can see x gets larger, y gets smaller. X gets smaller, y gets larger. But again, it doesn't have to necessarily be a linear relationship. It can be parabolic. It can be a curve like that, or it can be a curve like this. Either way, you can see if the x value gets larger, the y value gets smaller. Okay, so for now, you have that worksheet posted. It's problem 7 through 36 on that worksheet. Somebody was trying to ask a question there. Sorry, I kept cutting you off. Go ahead. Our next test is May 2nd. Test 4 is on May 2nd. Test 5 is going to be on May. I gotta pull up my calendar here so I actually get the dates. Technically, our last class was on May 16th. We will do our last test on May 14th. That'll be test 5. Then May 16th, that's going to be dedicated to doing corrections. So if you have any questions on test 5 that you need answered so you can do corrections on it, and then also extra credit. So that, you bet. Okay, that is everything for today. So you guys have a great day, and we'll see you on Friday.